Hello colleagues, my name is Stephen Bornheimer and I'm going to be narrating this presentation on hydrogen, the first and the best element in the periodic table. Before I begin though, I am recording this presentation with an app called Explain Everything on my iPad, and if you're interested in how what app this is or how it works, you can go ahead and email me or contact me via the discussion board. So here we go. Hydrogen is one of the most abundant elements in the entire universe. It constitutes almost what scientists believe to be almost 75% of all matter in the universe. And the reason is that hydrogen mainly is what our stars are composed of. See, our stars, they undergo fusion, and when hydrogen fuses into helium, like our own sun, and this reaction, this fusion reaction, produces immense amounts of energy. Now, this fusion takes place because of the immense amount of gravity inside the star, and we would see that, and looking at the universe, looking at nebula and the formation of stars, using radio telescopes, we're able to see that most of what matter is in the universe is hydrogen. So hydrogen is incredibly abundant, and it's no surprise that it is also very abundant here on our own terrestrial planet. Okay, here are the basics of hydrogen. First of all, it has three different isotopes: protium, deuterium, tritium. Generally, though, we consider protium to be what we oftentimes reference when talking about hydrogen, which means that it has one proton, one electron, and 0 neutrons. And the reason is that protium constitutes about 99.98% of all hydrogen in the universe. It has a 99% or almost 100% abundancy. There are other isotopes even beyond the first three main isotopes of hydrogen, but their abundance is so minute and their lifespan so small that they're almost considered negligible. So, and you can see that the different isotopes also have different atomic masses. However, we see that the atomic mass in the periodic table most closely resembles protium because of the abundance of that particular isotope in the universe. Hydrogen has an atomic number of 1, an atomic symbol of H, atomic name hydrogen, and atomic mass 1.00794. When referring to the mass of a single atom, these units would be atomic mass units. However, if we were to look at a mole of substance, or if we were to look at a large quantity of hydrogen, we could also say that this atomic mass is 1.00794 grams per mole, which we call molar mass. Hydrogen has many unique characteristics. The image to the right there is actually a hydrogen gas being excited in using a high voltage source or a high voltage power source. If you have any of these high voltage power sources in your classroom or have seen them in high school or college, they're kind of special looking light bulbs or tubes of gas, and when we excite them, they give off a very unique spectral color. We can use spectrometers to actually measure the spectral lines produced, which are unique to each element. And hydrogen has a very unique and simple spectral line, or spectral lines. Hydrogen is in essence colorless when in normal state. When excited, obviously not so. It is odorless. It is a gas at room temperature. It's a diatomic molecule, meaning that it exists in pairs. It does not really exist by itself. It is highly combustible. It is tasteless, non-metallic, has an incredibly low melting point, and a very low boiling point. And one of the things that probably should be noted is that, to give perspective, the melting point of N2, or nitrogen gas, is 63 Kelvin, and the boiling point is 77 Kelvin. So actually, hydrogen, in order to melt and boil, must be colder than liquid nitrogen, just to give perspective. Kind of a little bit of a history of hydrogen. Hydrogen was truly first recognized as a substance by Henry Cavendish in the 1700s. Now, this diagram on the right, or this image, is actually a GIF animation. And if you were to look at it in a normal PowerPoint presentation, which I will post on the discussion board, you would see that this is a scientist from the University of Leeds that's lighting several balloons of oxygen, or one balloon of oxygen and 3 balloons of hydrogen gas. And when ignited, creates an incredibly large ball of fire. Why this is relevant is because Cavendish was the first one to realize that if you have this gas, which we ended up naming hydrogen, When it combusts, it's actually the synthesis of water. It puts together oxygen and hydrogen to create pure water, and it is a very clean reaction, meaning that unlike a lot of fire or where we have, where we're burning either a hydrocarbon, or we're burning wood, or we're burning organic material, when hydrogen combusts, the only product is water, which is incredibly clean. So anyway, it's really quite fascinating, and Cavendish is credited with really kind of naming or discovering hydrogen. So now this is kind of the combustion reaction you can see here. You see that we have two hydrogen molecules, diatomic molecules, combining with one molecule of oxygen gas to produce two water molecules. This is a balanced equation in its pictorial form. We see that we must have two hydrogen molecules in order to perform a single combustion reaction between hydrogen and oxygen. And this is because hydrogen gas and oxygen gas come in pairs, and we have to have at least one of each. So in order to combust both oxygens, we need two molecules of hydrogen, diatomic hydrogen. Now, when Cavendish first started looking at this reaction, he noticed that water was formed, and so the word hydrogen itself actually means water former. So this reaction is kind of the essence of what hydrogen was all about, and why it has the name that it does. So to kind of give you an idea of hydrogen and some of its plentiful uses, we kind of want to give a little bit of credit to hydrocarbons. One of the great many uses of hydrogen is in hydrocarbons, and we use hydrocarbons all the time. Some of the kind of common hydrocarbons are called alkanes, and you can see them as methane, ethane, propane, butane, pentane, hexane. There are others: heptane, octane. You might recognize the word octane from meaning like high octane fuels. Propane, obviously, methane. These are obviously flammable gases, but the reason they're called hydrocarbons, and they're kind of didn't really hold the formatting here on this slide, is because they're just made of carbon and hydrogen. So we see that when they combust, meaning we react them with oxygen, they produce CO2 and H2O, and they can also produce an incredible amount of energy because of the bonds between hydrogen and carbon. So when these bonds break, or when they separate out and then form new substances, we see a lot of energy produced, and that's why methane, propane, butane, these are common fuel sources for us here as a human race. Hydrogen is also very common, or very popular in acids. It is a key component in acids, and acids and bases obviously have some unique properties, but hydrogen is attributed to being in both. Not only you have hydronium and hydrogen in acids, but you also have hydroxide in bases, and so and you have hydrogen or proton donors and proton receivers for acids and bases. So one of the cool things is that acids and metals, when they first were put together many years ago, chemists first started to realize that gas was produced, and then they realized, oh, this gas is flammable. And it just so happens that when you have a single replacement reaction, gas is oftentimes a byproduct. And so you can actually do a simple reaction at home, kind of an experiment. You can take a penny post 1982, and you can put it in household muriatic acid. Now, this acid can be bought at Lowe's for about $7 to $8. Actually, I just bought some. And these pennies, you probably have them in abundance somewhere in a jar or a piggy bank. And if you scrape the edge of the penny off using a file or sandpaper, it'll expose the silver metal underneath, which is zinc. And zinc reacts with hydrochloric acid. The reaction is a single replacement reaction where zinc kind of comes in and kicks hydrogen out, and obviously then hydrogen gas is produced. So you see the production of zinc chloride and hydrogen gas. And there is a YouTube video here you can watch. This is a live link on the real presentation. And one of the cool things about this particular YouTube video, which you can kind of see the link here, is that this YouTube video kind of walks you through the process of doing this. What's cool is you end up with an empty penny, which is really cool to show students or just your children, or just for you to have fun. So kind of a neat experiment that you can perform with household chemicals. Now, hydrogen by itself doesn't really conduct electricity. However, acids do conduct electricity, and part of it is that when they're in aqueous state, they're really kind of ionized, and we could go into the nature of strong versus weak acids and their ionized properties. But for the most part, because of the ionization of acids in an aqueous solution, they do conduct electricity. So kind of hydrogen does kind of contribute to the conductivity of particular substances. You can also see that if you have water in an electrolyte solution, you might also gain some kind of conductivity, which is inadvertently related to hydrogen. However, kind of talking not necessarily about conductivity, but about electricity, electricity can be used to split water into hydrogen and oxygen, and this is a very unique reaction called electrolysis. And it's the process by which we use kind of platinum anodes and cathodes to separate out water and to produce oxygen and hydrogen gas. Using the anode and the cathode, obviously, if you can see in our diagram here, the anode, which is right here, is oftentimes attributed with the production of oxygen gas. The cathode here is oftentimes attributed with the hydrogen gas. And so this is kind of a neat demonstration. Very kind of difficult to set up well, but if done as a demonstration can be really quite entertaining. And you can also then release some of that hydrogen gas and trap it in a balloon and then put it over a candle, and you can show the students some of the combustible natures of hydrogen. So here's my bibliography. If you're curious about that animation, it's from the University of Leeds. The propane tank image, sun image, and electrolysis were gathered online, and the Meratic image is my own. So thank you for watching my presentation on hydrogen gas. I hope that it was informative, and I would encourage you to go out and try the one reaction between muriatic acid and a penny. It is really quite fascinating and a lot of fun to do. So thank you for watching, and have a wonderful evening.